So in this video, I'm going to show how you can build a toggle switch using SBOLCanvas and the MIT BU Cello Gate library. First thing you need to do is navigate to sbolcanvas.org. You can then enter the name of the ID of your design, the name, and a short description. At this point, you can go and start adding parts to your design. So I'm going to be first adding in the input sensor. In a previous video, I had created a parts library on SymBioHub. So I'm going to log into this, the living computing instance of SymBioHub where the Cello library is found, and navigate to that parts library that I built and find the TED-R sensor. So I've added that to my design. So now the TED-R sensor produces the TED-R protein. So I'm going to add that into my design. I'm going to indicate it's produced by that by selecting the two parts and selecting the production arrow. So I might want to indicate that these are related to each other. I can do that by setting a color and making them the same color. Now TED-R binds to a small molecule. That small molecule is ATC. And it binds to form a complex, so I'm going to use this association node to indicate that. And add the complex to my diagram. Give that a name. Then indicate that these are binding. Add in the appropriate connections to this association. And there we've built the input sensor. So next I want to add the first half of the toggle switch. And so in this part, we're going to have two promoters in an engineered region. So the first promoter needs to be repressed by TED-R. So that is the PTEP promoter. And then the second promoter is going to be repressed by PHLF. And then finally, the engineered region produces the molecule AMTR. So you see this comes in with this indicator here that indicates their substructure. So we can go and see this is actually composed of a RiboJ, RBS, coding sequence, and terminator. Okay, so this circuit, as I said, has a repression from TED-R. So we can indicate that like so. And maybe we want to indicate this also by color. And then this produces AMTR. So let's add that into our design. So the AMTR protein. So it's produced from here. And then lastly, I want to add in the reporter that's controlled by AMTR. So that is going to have a promoter that's repressed by AMTR and engineered region to produce YFP, or the yellow fluorescent protein. So we import the AMTR promoter, and we're going to import the YFP reporter. Once again, you can see that there's substructure here for the circuit that produces YFP. As I mentioned, this presses this promoter, And then this produces the YFP protein. Indicate that like so. And just for some finishing touches, maybe we will add some color to our diagram. And at this point, we've added half of the toggle switch. We now have to add in the lac-eye sensor and the other half of the toggle switch. And this is the entire toggle switch put together. And that concludes this demonstration.